Allison.
I'm Brian.
I'm Latrice.
And welcome to our cooking show. Today we will be making churros using AP Calc equations. So let's get started.
So for our first ingredient, we'll be adding our flour. So let's pass it to Latrice, who'll be helping us solve for how many grams we'll be needing today.
Solving for the slope of a tangent line for flour, which is 120 grams. So first, we use f of x, which is 4x squared minus 5. And then we'd have to use the power rule, which gives you f prime of x equals 2 times 4x to the power of 2 minus 1. And then that moves to 8. F prime of x is 8x. And then f prime of 15 for x. And then 8 times 5 is 40. 8 times 10 is 80, which gives you 120 grams for f prime of 15.
Thank you, Latrice, for finding out how much flour we need, and now I'll be scooping it in. Let's get our dig on. This is a half cup measuring spoon. And this is our second half cup, which makes 1 cup. We have our flour. We'll be passing it on to Allison to figure out how much butter we need to add to the pot.
Thank you, Brian, for pouring in our flour. Next up, we'll be needing to find out how many tablespoons of butter that we need. We'll be solving for this by using absolute maximum, and we'll be needing 6 tablespoons of butter. So our equation that we have is negative x minus 6 squared plus 10 with the points 5 and 7. So first off, we need to plug in both of our points. So we'll start off with 5. So instead of x, we'll be using 5. And then, yeah. So f of 5 equals negative 5 minus 6, which is negative 1 squared plus 10. And then after this gives us negative 1 plus 10, which is 9. So now we know f of 5 equals to 9. And we'll now be plugging in our next point, which is f of 7. So negative 7 minus 6 plus 10. And then 7 minus 6 gives us 1. And then plus 10 squared. And then 7 equals, so 1 squared is positive 1, and then we move the negative that's on the outside to the inside, which also gives us negative 1 plus 10, and then this will give us f of 7 equals 9. So now that we know that our absolute maximum has to be between 5 and 7, since f of 5 is 9 and f of 7 is also 9, we need to plug in f of 6 since it's the only number that is in between both of them. Cut. Double checking for f of 6 to see if it is our absolute maximum. So instead of f of x, we'll be plugging in f of 6, and then so 6 minus 6 squared plus 10, and then this gives us 0 squared plus 10, and then this gives us 0 plus 10. Now we know that f of 6 is the absolute maximum when 6 equals x, when 10 equals y. So now that we know we need 6 tablespoons of butter, now we will be cutting to Latrice.
Thank you, Allison. Let's butter this up. I can't do this. Oh, it's good enough, right? 5.
Yeah.
We'll be solving for the sugar. Let's make things sweet. I'm going to be using the definite integral to find out how much sugar we need for our coating. So we'll be starting off with s of x equals 2x minus 3. And then since we're doing an integral problem, we're gonna be using the antiderivative, which will be 2x with this invisible 1 there. And then whatever this is, which is 2, you make it the denominator, and then you add a variable to 3. So now that we've found the antiderivative, we need to plug in the lower bound and the upper bound for the antiderivative. So s of 4 would equal 2 by 4 squared over 2. That crosses out minus 3 by 4, which would leave you 16 minus 12, which gives you 4 for s of 4. For s of 9, you'll have 2 by 9 squared over 2. That crosses out minus 3 by 9, which gives you 81 minus 27, which equals 54. After you find the upper bound and the lower bound, you subtract the upper bound from the lower bound, which will give you 54 minus 4, which gives you 50 grams of sugar.
Thanks for finding out how much sugar we're going to be needing, and now I will be putting you the sugar. Added sugar, I'm going to be using the volume of a rectangular prism to find how many grams of water we need, which is 120 grams. As we know, the volume of a rectangular prism is length times width times height. As we know, the width is 3, the height is 4, and the length is 10. So we're going to plug in each value. So volume equals 10 for the length, 4 for the height, and 3 for the width. And we're going to use that to solve. So 3 times 10 is 30 times 4. V equals 120, which is how many grams of water we need. Now, our dear friend Allison is going to be pouring in the water.
Thank you, Brian, for finding the volume of a rectangular prism. Now we will be adding our 120 grams, aka 1 cup of water, into our pot.
Thank you, Allison, for pouring in the water. And now we're going to be using related rates in order to find out how many teaspoons of salt we're going to be needing, which is 1/2. And in this problem, we are given that the water is being poured into a cylindrical pot at a constant rate of dV over dft is equal to 2 pi cubic meters per minute. The radius of this pot is 2 meters. And the question is, how fast is the water rising when the water is 1 meter high? So now we're going to be using the information given, which is a cylindrical pot. In order to find the volume of a cylindrical pot, we had to use this equation. V is equal to pi r squared times h. And we are also given that the radius is 2 meters. So now we have to plug that in. So pi 2 to the second power times h, which is basically just 4 pi h. And now, in order to factor out the h, we had to divide it with the respect to time, the derivative of time. So it's going to be d of v over d of t is equal to 4 pi times d of h over d of t. We are also given d of v over d of t, which is 2 pi. So we're going to plug that in. So 2 pi is equal to 4 pi times the derivative of h over the derivative of time. And now we're going to divide 4 pi in order to get it to the other side. And as you can see here, we can simplify that. So it's going to be 1/2 is equal to the derivative of height over the derivative of time, which gives us the rate at which the water is rising when the water equals 1 meter high.
Thank you for finding out how much salt we need. Now I'll be adding our 1/2 teaspoon of salt.
Now for our special segment, point of inflection, accent surprise.
I should have came on Tuesday. Now I have all these equations to solve. And Allison isn't even here to help me. Miss Sharp.
She ain't here, bro.
Brian, can you help me with point of inflection?
No, you should have done those equations on your own. Why am I doing everything here?
You're not even in this period. What are you doing here?
Mr. Campbell let me go.
Hi guys, sorry I'm late. I was scrambling to get my things done. Can you please excuse me from my absence?
Allison, you're here. Can you call Miss Sharp?
Like, whatever.
I need help with point of inflection. Let's get to our equation. Do you know the function, Brian?
How do you not know your own equation? The function is e of x equals 3x squared over 6 plus x squared.
Trees, what are you doing?
Cowabunga!
Oh, the trees.
So we'll have to put the eggs in one at a time. So here's the tree. She's gonna be scrambled. Look at her, she's scrambled.
Oh, yeah.
Into the bowl she goes.
No.
Guess who'll be joining her next? Is it you, Brian?
Has got to be yoking me. I guess I'll join her. So exciting.
Well, this looks like the exact amount of eggs that we need.
Thank you, Latrice, for this excellent segment.
Now that we've mixed in our eggs, we'll be adding 1 teaspoon of vanilla. James. Integral churros.
Now I'll be finding our frying time by using area bounded by curves. We're given that f of x is equal to x plus 10, and it's stated that it is our upper function. We're also given that g of x is equal to x, and that it is our lower function. We are also given that it is between the closed interval of 0 and 9. As you know, in order to find the area between curves, you have to subtract the lower function from the upper function. And in this case, it's f of x minus g of x. And since this is a calculator-based question, you would have to plug in the following in order to get the answer. The integral of 0 and 9, f of x minus g of x dx, and you will get the answer of 90. That is our frying time.
Thank you, Brian, for figuring out our frying time. Well, now let's get to frying.
Just wait until the next batch.
Look at what this dude did. Oh, that's crazy. Thank you for frying our churros. Now we will be starting with the dip by finding a relative minimum with 2/3 cups of heavy cream. So in order to find a relative minimum, you need to find h prime of x, or when h prime of x is equal to 0. So h prime of x will give you 2 times 3x squared minus 1 over 2 minus 2, since the x is gone now. H prime of x will give you 6x over 2 minus 2, and then after you find that, you set h prime of x equal to 0. So when h prime of x is equal to 0, 6x over 2, which is just 3x, minus 2. You need to find 3x minus 2, and 3x minus 2 is equal to 0 by adding 2 to both sides, and then dividing 3 on both sides to get 2/3 cups of heavy cream, which is the relative minimum for the equation.
Thank you, Latrice, for solving our heavy cream. Now let's get started making our dip. I will be adding our 2/3 of chocolate chips. That's 1/3. That's 2. Next up, we'll be adding our heavy whipping cream that our friend Latrice solved for. So we also will be needing 2/3 of that. That's 1/3. We'll be adding a little bit of cinnamon for some flavor, and then popping that into the microwave at 30-second intervals at power 5, just to make sure our texture isn't too chunky. Get it? Intervals. This is our dip. Alright, so for our coating, we will be solving it by using limits. So the equation that we have right here is as x approaches negative infinity, 3 plus 2x to 2 to the power of x, and we have 4 minus 5 to the power of x. So our first step is to plug in negative infinity, but since negative infinity is boundless, it's equal to 0. So what we're gonna do is plug in 0 for our equation. So this becomes plus 0, and this becomes minus 0, and then we know 3 plus 0 is 3, and we know 4 minus 0 is 4. So our answer becomes as the limit approaches negative infinity, it is equal to 3 over 4. And that is how many cups of sugar we'll be needing. Alright, so next we'll be solving our how many teaspoons of cinnamon we need through average value. The function that we have is f of x minus 4, and then with the intervals at 1 to 5. We are double checking for C though, because we need 2 teaspoons, so we'll be fact checking that with an interval between 1 and 5, which will be our C value. So to begin with, to find our C value, we're gonna use the average Y value, which is 2, and so we're replacing that. So we have 2 equals 2x minus 4, and then this is where we just solve for x, and then this gives us 6 over 2. Okay, I just know mental math, okay? And then this is 3. So this means that C is equal to 3. C is equal to 3. And then F of 3 equals 2. And then this is how many teaspoons we have.
For solving for our coding, and now I will be coding it.
It is now 8:04, and we are done with our integral churros. Yay! Thank you for watching our cooking show. A+.
Catch you on the flip side.
1, 2, 3.